Hi everyone, welcome back to my number sense series. In this video, we're going to talk about multiplying by 11. Now, if you recall your times tables, you might remember that multiplying by 11 seems to be really easy. For example, 5 times 11 is just 55, that's 5, 5. 7 times 11 is just 77, that's 7, 7. So you might be tempted to think that the pattern for multiplying by 11 is to just say the number twice. But if we do something like 12 times 11, clearly 12 times 11 is not 1, 2, 1, 2. It's 132. So why does that pattern break? Well, it's not really that the pattern breaks, it's that the pattern is something that's more complicated than what you're thinking of. And to see this, we have to think about what 11 is. The reason you get these nice properties like 7 times 11 is 77 is because 11 is actually 10 plus 1. And what's nice about 10 plus 1 is that 10 is actually just 1, but with a place value shifted. So when you do 7 times 10 plus 1, for example, you're doing 7 times 10 plus 7 times 1, and this is really just 70 plus 7. And so you can see that you have a 7 here, you have a 7 here, it just happens to be in the tens digit and the ones digit, which is why you get 77. But this is a little bit different for a 2-digit number, right? For example, let's try to do 34 times 11. By expressing 11 as 10 plus 1 again, we can say 34 times 11 equals 34 times 10 plus 1. And now we'll use the distributive property again. And so we can say it's 34 times 10 plus 34 times 1. And 34 times 10, of course, you just add a 0 to the end, is 340 plus 34. And so now when we do this addition, this 0 plus 4 is a 4, 4 plus 3 is a 7, and we have a 3. So if we're trying to look at how does this look similar to this, we'll see that, okay, we have a 4, we have a 3, but where does the 7 come from? Well, the answer is that the 7 is actually just 3 plus 4, and this is the pattern for 2-digit numbers. And we'll be able to see this in a different way when we think about just doing like the normal, quote, 2-digit multiplication way. So let's do 34 times 11 over here. 4 times 1, 3 times 1, and we'll do 4 times 1, and 3 times 1. And again, when we drop this down, when we add everything up, we'll see we have a 4, we have a 3 plus 4 makes 7, and we have a 3, 374. So we can see that when we're trying to multiply 2-digit numbers by 11, what we should do is we should take the last digit, we should keep it, we should take the first digit, keep it, and then our middle digit will be the first digit plus the second digit. So let's try to do this with another number like 86. You can pause right now if you'd like to try it, but beware, it will be a little bit more complicated. So with 86, you might be tempted to just do what we did right here. And of course, you wouldn't be wrong, really. You'd just be doing it a little bit different. And you wouldn't get quite the right answer if you just tried to write the numbers out. Because we have a 6 here, okay? But in the middle is 8 plus 6. 8 plus 6 is 14. So if you write 8146, I would understand where you got that from, but it's definitely wrong because it's not going to be 8,000 something. What this 14 is it's 14 tens, which would actually be just 140. So when we add these two digits and we get something greater than 10, what we should actually do is carry it over. So if we wanted to do 86 times 11, I'll just show you right now using the distributive property again. It's 860 plus 86. And then we can see that when we try to add the 6 and 8, we'll get 14, but it's 14 tens. And so this is going to be like a 1 that carries over into the hundredth digit. So the answer is 946. And the hundredth digit isn't 8, but it's 9 because it's 8 plus the 1 that's carrying over from the 14, where the 14 is 8 plus 6. So if we wanted to just do this in our heads without using this idea, what we would do is we would write 6. It's always ending with 6. But the middle digit is going to be 8 plus 6. 8 plus 6 is 14. So we're going to think about, okay, I can't actually write 14 because I only have one digit. So I'll write 4 and I'll carry the 1. And then our hundredth digit, it would be an 8, but I have a carried 1. So it's going to be 9. And so our answer is 946. Now, these two examples are pretty much going to show you how to multiply any 2-digit number by 11. It's just a matter of if you carry or you don't carry. But if you understand how it works, it'll be very, very intuitive and you won't have to memorize. Now, of course, this this idea of splitting up 11 into 10 plus 1 doesn't only work for 2-digit numbers. It'll work always. And so we'll see that it also works for 3-digit numbers. For example, if I try to do 123 times 11, you might be able to kind of guess what the pattern is, but I'm just going to show you to be certain. So 123 times 11, again, it's 123 times 10 plus 1, right? So it's 1, 2, 3, 0 plus 1, 2, 3. And so when we add this together, okay, my 1's digit is going to be 0 plus 3, so it's just going to be 3. My 10's digit is going to be 3 plus 2, which is 5. My 100's digit is going to be 2 plus 1. And my 1's digit is going to be 1. So, again, we can see that it looks kind of similar. I have a 1 at the start and I have a 3 at the end. It's just this 3 and 5. But if we look at this, again, this 5 was 3 plus 2, and this 3 was 2 plus 1. It's kind of like this, but here, 2 of our digits come from adding instead of just 1, like the 7 here or the 4 here. So again, we're in number sense, so we want to be able to do this in our head. So if we wanted to do this in our head, here's what it would look like. Again, always put this 3 at the end. It's not going to change ever because you can't carry into the last digit. So it's going to be 3. Now, the next digit is going to be the sum of these two. So 2 plus 3 is 5. And nothing carries. Nothing carries. So carrying is still a thing, but here nothing carries, which is nice. And now my 100th digit is going to be 1 plus 2. So notice that I kind of took this 2 and 3 and I shifted it over by 1. And this is the pattern that we're going to use when we even extend to 4-digit numbers. So when I take this 1 and 2, it gives me a 3. And my first digit, no carrying, is just going to be a 1. So that was a 3-digit number without carrying. How can we do a 3-digit number that's going to have carrying, like 365? Now, 365 is a little bit more complicated, but it's the same idea with carrying as we had previously, like with 86. So you can feel free to pause if you'd like to try it. Okay, so 365 times 11, just to make it a little bit more clear what's happening last time, I'm going to write 11 as 10 plus 1, and I'm going to use the distributive property. So I'm sure you can tell by now, it's because it's going to be 365 times 10 plus 365 plus 1. So it's 3650 plus 365. And so now when we add this, we're going to get 0 plus 5. Again, notice that the last digit is always going to be 5. It's always going to be the last digit of whatever is going to be multiplied. And now we're going to have 5 plus 6 is, so you might want to write 11 if you're just doing it in your head. But here, of course, we're just going to write 1, and we're going to carry that 1 over. And so now our next digit is going to be 6 plus 3, but also plus that carried 1. So it's going to be 0 here, it's 10, and we're going to carry another 1 over, 4. But of course, we can't really set this up if we're doing number sense, right? It has to be all in our head. So I'm going to show you what it would look like if I wanted to do this purely in my head. So again, I'm always going to write the last digit of this one as the last digit of our answer. So we're going to work right to left. And so now, just like here, when my 10th digit was 2 plus 3, here my 10th digit is going to be 6 plus 5. But remember, 6 plus 5 is 11. So we're going to just write 1, and then we're going to remember in our heads that next time we add for this one, we're going to have to carry over. So 3 plus 6 is 9, but also plus 1, because we carried, so it's 0. And now it's 10, so the first digit is going to be 3, or it would be 3 if we didn't have a carried 1 from the 10 earlier. So now it's actually going to be 4. And it's going to be 4,015. And so this is actually a problem with 2 instances of carrying, but it's really the only thing that you have to keep track of when you're doing this. Basically, adding numbers and carrying is pretty much it. And you'll always write right to left. So our last example is going to involve a 4-digit number. But really don't be intimidated. It's literally just the same as like a 3-digit number or a 2-digit number, just with an extra digit. It's going to be essentially the same pattern of like the 1s, the 10s and the 1s, the 100s and the 10s, but now we have also the 1000s and the 100s, and also our first digit is the 1000s. So one last time, I'm going to write it out. 2538 times 11 is 25380, which is 2538 times 10, plus 2538, which is 2538 times 1. And so when we add this up, our last digit is going to be 8. Our 10th digit is going to be 8 plus 3, but remember, it's carrying. We're going to have 1 plus 3 plus 5 is 9, 7, and a 2. So again, it looks extremely similar to what we've done before, but just with an extra digit. So we should think about, like, I can just do this in my head also. If I can do this in my head, if I can do this in my head, then I can of course do this in my head because it's really just the same thing, but a little bit longer. So let's do this in our head without looking at this. So what should we do? First of all, of course, write the last digit is 8. And now my next digit will be this plus this. 3 and 8 makes 1. So we've had a lot of 11s today. So our next digit is going to be, like, kind of take the 3 and 8 and then shift it right once. So it's going to be 5 and 3 makes 8, but plus 1 from that 11 that we carried, so it's 9. And 5 and 3, okay, our next digit is going to be that shifted once again. 2 plus 5 is 7. And my first digit is going to be 2, and there's no carrying, so it is just 2. And that is my final answer. So, I mean, if you can do this in front of your friends, they're going to think you're really cool. Because to someone who doesn't know what's going on, I mean, this is like magic. But of course, if you understand that we're just saying 11 is 10 plus 1, it becomes extremely intuitive. And so this trick, you shouldn't really forget. Or you can kind of remind yourself of how it works by just doing like a smaller example, like 34 times 11 in your head. But really, once you get this pattern down, once you get this algorithm down, like take the last digit, shift, 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 first digit, it's really easy. And this is going to be a very crucial multiplication trick just in number sense, and it's very useful just generally. So I hope you guys understand this trick, understand why this trick works. Take